All right. So we are talking about the ambiguous case today. This happens when you have a side-side angle triangle. If you remember from geometry, you had all your congruence theorems, angle, side, angle, side. I don't know what your geometry teacher told you, but I always said there's no ass in math. Angle, side, side. We don't do bad words in math. So that was not a way to prove triangle congruence. It was not a guarantee that there was only one way to build that particular triangle, which would force congruence. That is why we get the ambiguous case. Ambiguous means, do we know what ambiguous means? Like, it could kind of go either way. Like, it's unclear what is supposed to happen. So the ambiguous case happens when you are given a pair of sides and an angle that is not between the sides, okay? Because since that's not a guarantee that there's only one way to build the triangle, that means there's actually two different ways that you could build it, okay? And so there's three possibilities of what can happen in this case. And this is, you're really gonna have to kind of think back to some of what you know from geometry here. I'm gonna switch, I feel like my voice is muffled. There we go, okay. So there's three things that can happen. One is that you have exactly one triangle, okay? It could be a regular, like, non-right triangle. Remember yesterday we said that's called an oblique triangle, or it could be a right triangle. How would we know? Because a squared plus b squared equals c squared. That's how we would know that it's a right triangle, or you get a 90-degree angle. Or it is possible that the pair of sides you have are too short to actually close the triangle. Like if I have the base of my triangle, okay, and I have two sides that are really short, like the goal is we take the two sides, we lean them together, they make kind of a house, and we have a triangle. If they're too short, the sides are just going to collapse in on each other, and there is no triangle that can be formed with those sides. So that is the possibility that you do your law of sines and you learn like, whoops, there's no solutions to this triangle. This triangle is impossible. The third option is that there are two triangles. If you kind of think of that side like it's on a hinge, you could have the obtuse angle, or it could swing in and you could have the acute angle. So if you see in this case where there's two triangles, we can get this triangle here, which would be an obtuse triangle, or we can get this outer triangle here. Both of those are possible with the same side length of A. So that's what we have to be checking for. The reason the ambiguous case occurs is because where is the sign positive? Which quadrants? 1 and 2. So that's 0 to 180 degrees. If we're talking degrees instead of radians, there's two different answers for sine in 0 to 180 degrees. And that's why this ambiguous case happens. Okay. So we're going to look at each of these three cases. Now on your notes, they're labeled. This one has one solution. So you know what to look at when you're looking at examples. On your homework, you're not going to know which one it is. So you have to kind of be looking for what are the clues you need to see. Okay, let's see. Where's my calculator? Got it. All righty. Make sure you're in degrees. I got to switch mine back. Nope, I'm in degrees. Okay, good. So this one has exactly one solution. It says solve the triangle, round sides to the nearest tenth, angles to the nearest degree. This is exactly like what you did yesterday. Okay, remember that to use the law of sines, we must have one complete pair, which we do. We know angle A and we know side A. So we have a complete pair there. So that's how we're going to start our ratios. Notice we can't start by figuring out the missing angle because there's two missing angles. So that makes it a little bit trickier. We're going to have to use sine inverse to find the missing angle, which is why this becomes ambiguous. Okay, so we have 81 is the side. Oh, let me switch this to a better color. All right, 81 is the side over the sine of 43 degrees because that's the angle. And now I know that B is 62. That's the only other side I know. And so that's going to be over the sine of B. So do you see why now we're going to have to use inverses? because now the thing that's missing is the angle, not the side. All right, so exactly the same way, we're going to cross multiply. And you may have learned this. I know your physics teacher always tells you this. These two are just going to switch spots in the end when you work this out. So you're going to end up having, we're going to cross multiply here. That gives us 62 times the sine of 43 degrees over 81 because they switch spots. And that's going to be equal to the sine of B. That's how that always works. Oh, what is that beeping in the hallway? You can close that door if that beeping is driving you crazy. Oh, well, you can close that door too. Close whatever door is bothering you. All right, so B then, whoops, I keep zooming, is going to be equal to the sine inverse of all of this stuff. 2 sine 43 degrees over 81. That's what you need to type into your calculator. And again, thank you. Do it all at one time. So go ahead and type that in. We get second sine inverse, 62 sine 43. Make sure you close those parentheses, divided by 81, close those parentheses. And you should get that B is 30, what does it say? Angle measures to the nearest degree, bless you. So that would be 31 degrees for B. Now we know this. Okay, now here's what we have to do anytime you have to do the inverse with the law of sines. This is what's extra about this today. We also need to think that the second option for angle B would be 180 minus 31, which would be 49 degrees. 149 degrees. That information tells me that it's not possible for me to get a second triangle. Why not? Raina, you got a guess? Olivia? Well, that's okay. We can't always go by what the picture looks like. She said because it looks like an obtuse angle and that angle is too small. Will? Yeah, you've already busted the triangle with two angles at that point. So what we're saying is the second option would be that this one is 149. Okay, there's two options for angle B. We know it's 31 or it could be 149. Well, 43 plus 149 is already bigger than 180 and we haven't even done the third angle yet. That's why this doesn't work. You have to be able to have three angles in your triangle, and we've already busted with that one there. So this is too big for 180 degrees in the triangle. So we do not get a second answer, and that's why there's only one triangle in this case, and the only option is the first value that we found for B. Okay, so what I want you to do now is do what you did yesterday. Now we know that angle B is 31, so can we figure out angle C? Yes, and then once you know angle C, you can figure out side C. So go ahead and do that right now. All right, did you get 106 for angle C? Subtract the 2 you have from 180. And then here's the proportion that we want to use. Again, we always want to use the highlighted pair because that's what we were given. We didn't have to round to get that number. 31 is nice, but we rounded that. So that's not going to be exactly what we get. So we want to use the pair we were given. So that means that C is going to be equal to 81 times the sine of 106 degrees divided by the sine of 43 degrees, and we get 81 times the sine of 106, close parentheses, divided by sine of 43. Is it a big number? Yeah, 114.2. Excellent. Okay. The only step we are adding today is this one here that you have to consider the second possibility, okay? If that second possibility allows you to still get three angles out of your triangle, then you have two triangles and you have to find the answers for both of the triangles, okay? Let's look at one where we have no solution. Can you think of what's gonna happen here? If I do a sine inverse, why would I get no solution? Not that it's bigger than 180, but you're thinking along the right lines. What do we know about sine? Why we want, sine has to be between -1 and 1. So if that ratio that you plug in, sine of whatever divided by sine of whatever, if that ends up being bigger than 1 or less than 1, you're not going to get a triangle. That's what's going to happen here. Okay, so another thing about this one that is different is they did not give us a picture. So we need to draw one. So it makes no difference whatsoever what your triangle looks like. This is totally arbitrary. Just sketch yourself a triangle. We don't know if it's acute, obtuse, right? Doesn't matter. Label your triangles ABC. So they told us that angle A is 75 degrees. So that's this one right here. Side A would be across from that. That's 51. And side B is going to be over here, 71. Okay. So don't stress if they don't give you a picture. So we're going to set this one up exactly the same way. We're going to say that 51 over the sine of 75 degrees equals 71 over the sine of, B degrees. We don't know what B is. Over the sine of B. So that means that the sine of B is equal to 71 sine 75 degrees over 51. And now we need to put that into our calculator, do your inverse, and see what you get. You should get an error. Okay. Again, why are we getting an error? That's because this number here is approximately equal to 1.3. That's why we can't do the sine inverse. So since there's an error, that's why the answer to this one is no triangle. It's impossible to build a triangle with those two sides and that particular angle. It can't be done. That triangle is going to collapse in on itself. It won't close. Okay. That's like best case scenario. You hope that you get a no solution one because they're very short. Two solutions is where it gets a little bit messier. The math is not any harder. It's the same thing. Law of sines, inverses, proportions, over and over and over again. But so here, this is another one. They did not give us the triangle. So take a second to yourself. See if you can sketch what that triangle would look like. All right, that's how I labeled mine, but yours might look a little different. It really doesn't matter as long as you have the sides in the right spot corresponding. You could have your A on top or your B on top. It doesn't matter. All righty. So we're going to start exactly the same way. This is the pair that we have a complete set. So we're going to say 54 over the sine of 40 degrees equals, I'm going to start by solving for angle B. That's the only option, right? Because that's the only one where we know anything else. So I have 62 over the sine of B. Now, you've seen a lot of these now, so you can kind of get to the last step all in one shot. I know that B is going to be equal to the sine inverse of, we're going to have, let's see, 62 sine 40 degrees over 54. We're going to call this B1. Put that in your calculator. 62 sine 40 divided by 54. What are we rounding to? Nearest degree. So I get 48 degrees. Okay. Any questions on that part? Now, just like the first example we did, we need to consider, what if I had angle B2? That would be 180 minus 48, which is 132 degrees. If there is a second B, is it possible then for me to have a second C? Are there degrees left over for my triangle? Yeah, if I do 180 minus 40 minus 132, we get 8 degrees. It's an itty bitty little angle, but we do get a second one. So we do have to consider then that we have 2 possible triangles. So then we would know that C1 is equal to 92. So here's what this means. We have, if this is B1, then this is 48 degrees and this is 92 degrees. If we have the second option for our angle, that means that we also have a triangle that looks like this, 40 degrees, 132 degrees, and then 8 degrees. Obviously, that's not to scale, but that's okay. This one is 62. This one is 54. Side C in both cases is now the last thing that we have to solve for. So this is going to be little c1. This is little c2. We just do the law of sines exactly the same way as we did in all the other ones to figure this out. So let's do the top triangle in blue. So here, based on this information, I have 54 over the sine of 40 degrees equals, let's see, what are we doing? C1 over the sine of 48, nope, 92. Sorry, that's the wrong angle. 92 degrees. We're doing this pair right here. So you can put 54 sine 92 divided by sine 40. And we get that little c1 is approximately 84.0 when you round to the nearest tenth. Since it asked us for 1 decimal place, you do need to have the 0.0, okay? If you just put 84 in my math lab, it's going to say you didn't round correctly, and so will I on the test. So read the directions carefully. And then lastly, now if we go down and consider the red triangle, we know that we have 54 over the sine of 40 degrees equals C2 over the sine of, this time it's going to be 8 degrees. We're using this pair right here. So C2 is equal to 54 sine of 8 divided by the sine of 40, 11.7. So really more what that red triangle is supposed to look like, since it has an 8-degree angle, would be something more like this. Your 132 is this obtuse angle down here. That's really what it would look like. We're not drawing to scale, but that's kind of what you're going for. So when do you have to check for 2 triangles? Anytime you use an inverse for law of sines. So anytime you use a sine inverse. So again, if we kind of summarize here what we're looking for, we always start by finding the first missing angle. Then we find the second possibility and see if it works. If it doesn't work, then you're done. You just have one. But if it does work, then you need to answer for 2 different triangles. Does that make sense? All right. That is it then for today.